Okay, so this is when you have fitted both the models, both the null model as well as the full model. Now in many cases you do not want to do that. You want to fit only the full model and then specify your null hypothesis as some kind of linear restriction on the parameters. If you want to do that, in that case, the first technique is something that you have described in class. You take that restriction into account, create a new null model, actually fit that using R and proceed like this. But most of the time you do not want to do that. You want to specify that matrix, you want to specify that null hypothesis symbolically into R and want R to create your restricted model, fit it and do whatever. Everything should be done inside. So if you want to do that, then you proceed like this. You have to load another package, that's car. So I will do that and I will use a different data set. This is also from the package far away. It's called coagulation and it has got two variables. The first one is a continuous one, that is the response, and the second one is diet. So if I just take a look at the things, so I will say summary and coagulation. So you can see that diet has got 4 levels, so there are A, B, C, D, and coagulation is a continuous variable with min, max, etc. And out of these things, A occurs 4 times, B occurs 6 times, etc. So you have this particular thing. So now suppose I fit this model, so it's a one-way ANOVA model, pretty simple stuff. I get this. Now I will just take a look at whatever is my fitted thing. I see that I have the intercept and diet B, diet C, diet D. So the model is actually mu plus alpha I plus epsilon ij, and there are 4 alphas. Not all of them are estimable. So as we already know, R will drop the first one. So diet A is dropped, which means it is forcefully set to 0 to make things unique. It's non-unique, so it has just put that restriction arbitrarily to give some particular least square estimator. And you have diet B, diet C, diet D. Now suppose you are interested in testing whether alpha for diet B equals alpha for diet C. So alpha B equal to alpha C, that's what you want to test. You can write it in this way. You can just write LHT, linear hypothesis testing, that's what I took from the car package. Then write down the model fit, something that you are declaring as a good fit. Then I can specify the hypothesis as a string, diet B minus diet C. Notice the way I am writing diet B, diet C. This name I am getting from the output of the LM. So inside my data, they were not called diet B, diet C. They were just called B, C. So you have to look at how they are written inside their fit, and you have to use that name, diet B minus diet C. I have not specified anything, so this means it is testing diet B minus diet C equal to 0. So let's carry out the test, and you get this test. So here the degrees of freedom is 1, so it means it fitted the restricted model somehow. There are actually shortcut ways of doing it, that's what it is using. But effectively it is fitting the restricted model and doing that RSS naught minus RSS thing, and it is getting that F statistic, the corresponding p-value is this. Now it could also specify not just this but equal 5. So this will test diet B minus diet C is equal to 5. Here you can see that they have written the hypothesis as diet B minus diet C equal to 0. So if you do not specify the right hand side, it will take it to be 0. Now if I do that, then I will have diet B minus diet C is equal to 5. So model 1 is a restricted model, model 2 is the general model, and they have tested it, and this p-value you can see is very small, much less than say 0.05, so it is highly significant, and they have also given you that significance level is a triple star gives you the significance score. So in this case you reject it. So that difference is by no means 5. And if you look at the last time, I had p-value is 0.1588. So diet B is basically same as diet C. Now you may be interested in testing something like, well, so before I go into that, so I can show how you can do the same thing using just a matrix notation. So remember that you have got, in this case, 4 parameters. What are the 4 parameters? So let's quickly see the 4 parameters that we had here. So I will write phi $coef. Sorry, I misspelled it. Coef. So they are intercept, diet B, diet C, diet D. So I can write the same thing as a linear combination 0, 1, minus 1, 0. So 0 means I am not taking intercept, coefficient 1 for diet B, minus 1 for diet C. So diet B minus diet C, no role played by diet D. I can do the same thing. So that will also give rise to the same result. Now if you make any mistake here, like you make it something smaller or larger, suppose you forget that diet A is dropped and you put a 0 for that, you will get an error message which is not very clear. What it says, error in L times B, non-conformable argument. So you understand that they are internally storing the coefficient in B and your restriction matrix in L. Incidentally, this could be a matrix. Here I am giving only a row vector because I have just only one restriction to put. If you have multiple restriction, put one restriction per row and look up the help of this function and you will see how things behave. You can look up the help of LHD and you will see exactly how you specify all this stuff.